They're bald, they're blind, they never get cancer, they are resistant to low oxygen, and they don't feel certain kinds of pain, for instance, chronic pain. A lot of people describe them as looking like hot dogs with teeth or sausages with legs. They're also cold-blooded. They live for 30 years, which is 10 times longer than other animals of the same size. Their teeth stick out through the skin, so they can never close their lips around their teeth. Their living conditions are horrible. They live in huge numbers of individuals within a colony, and so the air supply is very limited, and they use up much of the oxygen and generate a huge amount of carbon dioxide. We would find these conditions intolerable. The research that we do here at the University of Illinois at Chicago is focused on how they've adapted to these low oxygen, high carbon dioxide environment that they live in. Their brain is very protective against low oxygen. It's taken tens of millions of years to make that adaptation so they can survive under low oxygen conditions. How can we apply that to ourselves? Well, in times of crisis like a heart attack or stroke, we have low oxygen supply to the brain. So if we can discover how naked mole rats have solved this problem, we can apply it to victims of heart attack and stroke. They live under very high carbon dioxide levels. And so we're trying to find out how it is that breathing in high levels of carbon dioxide is not painful. If you've ever had a club soda or a carbonated beverage and you have a little burp through your nose, it stings like the devil. And that's because of the carbon dioxide coming into contact with your nasal cavity. The naked mole rats have several adaptations that make that not painful. The reason that that's important to us is because that pain system that responds to carbon dioxide is the same one that's involved in chronic pain. For people that suffer chronic pain day to day, it would be great if we could come up with new targets that we could try to use for therapeutic treatment. In their colonies, they designated different parts of their living space for different functions. So for this colony, they've decided that this cage right close to me is the home nest, or the kitchen, where they do food preparation, food sharing, etc. The next chamber over is the toilet chamber, and it makes sense for animals that are living in a closed environment like this to have one designated toilet for everyone to share, and then the other are just living chambers. They live in Central East Africa, where they're actually considered to be a pest. If a farmer decides to irrigate a field, the naked mole rats will go underneath of that field, and when the vegetables get ripe, just like the goofy gophers from our childhood cartoons, they pluck the carrots and potatoes. Naked mole rats have a very unusual social structure. Within a naked mole rat colony, there can be up to 300 members, but only one female breeds, and she's referred to as the queen. She will select 2 or 3 males to be her breeding bait, and all of the other adults are non-breeding helpers, divided into 2 castes. One is the soldiers, who don't take care of the babies, don't bring food back to the nest, don't clean up any messes, but if an intruder comes, they're on the scene. They will attack the intruder. The other caste is known as housekeepers. They keep the tunnels clean from debris, they do the majority of the digging, they carry the babies from place to place, they carry food back to the babies. All of these animals do the bidding of the queen. She makes a circuit through the colony every day, a couple times a day, and everybody she meets, she grabs them with her teeth and gives them a shake so they remember who's in charge. Ours is not the only lab working on naked mole rats. There's a group in San Antonio that's working on longevity and cancer resistance. There's a group in Berlin that's working on pain insensitivity. There's a group at Harvard working on genomic aspects. And I think that this is going to turn out to be a gold mine for biologists and biomedical research.